So in this question, we have a scenario where we have a fluorescent lamp fitting connected to a 230 volt supply. So here's our live and our neutral. And we've 3 meters connected to the supply to this lamp. So we have an ammeter, a voltmeter, and a wattmeter. And we're given readings on these 3 devices. So the ammeter is telling us that the current flowing in this circuit at the moment, I, is equal to 0.7 amps, and the voltage coming across the supply is 235 volts. And the wattmeter is telling us we have a reading of 128 watts. And the question is asking us, using the readings on each of these devices, work out the power factor of this circuit. So just to refresh our memory on power factor, what we're dealing with here when we talk about AC power is we have to consider the power triangle. Okay? So our power triangle deals with 3 powers. We have real power P, which is measured in watts. We have reactive power Q, which is measured in vars or volt amps reactive. And then we have S, which is our apparent power, which is measured in volt amps. So when we want to measure S, it's actually just the voltage times the current, V by I. And our real power, P, is V times I times our cosine of our phase, theta. And if you ever need to calculate it as well, Q then is V times I times the sine of the phase. So how are we going to use these 3 measurements to work out our power factor? Well, we have P. The wattmeter gives us P, our real power. It's 128 watts. Now, using I and V, the voltage and current, we can work out S. So that'll be V times I is equal to 100 or equal to 235 multiplied by 0.7, and that comes out as 164.5 volt amps. Now if you look in your formula book in AC formula on the bottom right, you'll see there's a equation for power factor. So from your formula, you see that there's one for power factor, and it says true power over apparent power. Now I used slightly different names here, but S is the apparent power. Right, if we use our voltage and current, we get our apparent power, and P is our true power or real power. So we have these 2 values. So it's really P over S, or sometimes you'll see it written as watts over volt amps in your formula book. So we have these 2 values, P and S. So we can work out that our power factor will be equal to P over S, which is 128 over 164.5. And we see that works out at 0.778. So because our fluorescent fitting has inductors in it, and not just resistance but inductors, we end up only getting 128 watts of real power, but our apparent power is higher than that, 164.5, which is why our power factor is less than 1. So not all the power being used in this circuit is real power. If it was, we would have a power factor of 1. And if you wanted, you could use this then to work out the phase angle, but it's not being asked of you in this question.